a vote free
Hello.
of any, well, fraud or potential fraud or dishonesty. We can't have higher standards about
Let's
the
see here.
integrity
Is
of
there?
every vote because what we're watching is like you couldn't think of a worse system, a more corrupt system where you literally, we've been watching this now develop for 4 years. Power hungry Democrats. You know, if you want to go to
Let me see. Let me see here. Let me see if I can just turn off the waiting room temporarily. Let's see if I can do that. Oh, there it is. Wait. Oh, there we go. Oh, I should allow people to flood it. All right. Let me see. Turn on chat. All right. Victor will be here momentarily also. Let's see here.
I was gonna say we could start brewing maybe, but we don't have Netherboard.
Settings, audio, turn this. Richard's not here yet. Let's see when he shows up. I can start helping anybody at this point. I don't know who wants to go first. You can, I guess, go in order that you arrive, maybe, or like maybe general question first. Here's what I'm gonna do. Let me do this, do that, and share. Which one do I want? This one right now. Okay. Uh, who um who wants to go first? Anyone? Okay. I do not see. Okay. So, does anybody have any questions they want to start with?
Yeah, somebody wanted you to go over question 1.
That's what I figured the issue was.
Yeah.
Yeah, that is the challenging the one. Well, it's not that it's actually challenging. The primary thing that makes one seem difficult is that the variables are named absolutely horribly.
Yeah.
So if we were to see, is there a way for me to write on this? No, I don't think. Can I? Can I annotate this? Actually, oh, I can. Oh, interesting. Okay, yeah, we can just do that then. So first thing, like I mean, this is odd. Oh wait, that's not the right color. We need to have a color that's actually visible.
So back to when I thought omegas was referring to multiple variables instead of omega s.
Oh, so
They just kept
so let's see, what's a good way. Okay, so what first thing you know just by looking at this statement right here. This it says your solution will be of the form will be of this form. Well, what if you recognize there's something that looks like a formula we were given, and that's that if you ignore this section for now, this is what the solution looks like to an equation that has imaginary roots. So this value in here, this omegas, this is actually just going to be your b value, which is the term that's on your imaginary term for your solution. So if for this one r ended up equaling well, that's an example, but r for imaginary roots is going to equal a plus plus or minus bi. So this b here just so happens to be omegas, will be that omega. But see, they didn't want to use b again because they already used b here. So they decided to come up with an even more confusing name. So this is your imaginary term right there. So that's the first thing, right? So you're going to need to break it up into two parts. So the best way to go about dealing with number one is to take a piece of paper and actually go through the process that you would do it by hand with. So down here, when they give you this example, it's pretty easy for one to do this one by hand. So if you do this by hand and you see the steps you take, you just end up coding those same steps. That's the key there to dealing with. Can I just erase this all? Is that clear? Okay. So that's the first thing. Omegas. That's what omega is referring to. Now this omega over here, omega f, just has to be referring to this term. Well, that ends up just being any ordinary coefficient in front of that t. In this g of t term. This ends up just being g of t right here. So what you're going to do is you're going to use this to get your y particular, which in this case, based off of what's given and what's being asked, because this is a single term being added on, you're just going to use this as your guess. This a times cosine wft is going to be, oh, but here's the even more confusing part, is that this a coefficient, this is not the a coefficient you would use in your guess. That is a separate a. This a is a given value and not the value you're looking for y particular. They just so happen to use a for some reason right there. They could have called it c and that would have been a lot better. So this ends up just being any ordinary value. It could be a 3, a 2, whatever. But so then your a, that's not the a you're actually looking for. So your guess would actually be, when you're doing this, is y equals a. And in this case, they call it AF for whatever reason. They could have gone away with A, but whatever, times the constant they gave you as your input, times the times cosine Yeah, room here. Cosine of omega f t. So that's your guess, right? So then of course you take your derivative twice. And what they make this a little bit easier because there is no y prime term over here. So because there's no y prime, this a little bit easier. You don't actually care about what y prime is from this. You just really need the y and y double prime from the guess. And then you just have MATLAB solve for your AF. And then that gets you your first output. One of the things they're asking for, one of the things they don't ask for is the actual solution from this. They legitimately only want these 4 things. So just by doing this first part, you get AF, and that's your first thing there. That's the first important thing. AC, AS, and omegas all come from doing your homogeneous solution. So that's where you would take let's see here, that's where you would take this and set it equal to 0, and then solve it just like any of the other second order differential equations you set equal to 0. In this case, it ends up being imaginary roots. And you already know to make your code work with imaginary roots every time, because they're saying your answer should be your general solution should be of this form, and this form right here is the general form for imaginary roots. This is the particular solution that was added on because of G of t. So now the thing is, they don't even ask you to give this whole thing as an output. They don't actually care about that. They just want these 4 things. So you can completely ignore this section after you get your AF. Then you only care about finding AC and then omegas and AS. Now, one of the confusing parts here is that again, that AS is not as simple as it may seem. Wait, did Victor show up yet?
Yeah, I'm right here.
Oh, you are?
Yeah, I should probably change the name of my GroupMe account because, you know,
well, yeah,
I obviously don't go by Vector V12 in real life. But anyway, yeah, I'm here.
So.
Well, I actually have the formulas if you want me to like screen share those for a second.
Oh yeah, that'll be good. That'll be a lot better than me trying to write it.
All right, sure. Give me 1 second.
Stop share. Is it enabled for you? Who can share? All participants. Okay.
Go. Let me pull up OneNote. Pull up the super secret documents. What is this? That is not it. So here's my derivation for actually it just occurred to me that this isn't actually, oh wait, no, it does fit all on one screen. Okay, so basically what I did was what Bob just suggested. What I did was I took the differential equation that they gave us in the problem statement, and I just worked out formulas for all the coefficients. And then using these formulas that I obtained, basically I just had my function just calculate the values of these individually. Oh wait, hold on. I just realized I never fixed the error that you pointed out. Sorry, I haven't. I haven't.
Negative, right?
The missing negative. I never fixed that. Here, let me go in there and fix that really quickly. Whoa, what is this? Sorry, this is taking so long. Where's a copy of some elevator music when you need it?
I might be able to share computer audio to specifically do that.
Yeah, I remember at one point I pulled up the song the music for the Atom Shop in Fallout 76, and I just played that in the background while I went to use the bathroom or something during one of the during like the last thing here. Anyway, I digress. I will take my draw tool, cross this out. Negative omega. Oops, that's a crappy omega. Omega f squared plus b. There. That's better.
Okay. Have you done it before? Like, I don't doubt your Minecraft skills.
You know, I should probably move.
It's really dangerous, you know, still 25 levels on you.
I should probably move this up.
No stop, no fear.
Yeah, that way I can zoom in a bit more, and then.
There's a bucket in one of the chests if you want to do it.
So the reason why it was like that is because usually I go like line by line like a computer does. So anyway, here I've repositioned it. It might take a few seconds to show up because I'm writing on my Surface and then I'm screen sharing on my PC.
No doubts.
So I have to wait for it to sync.
I can never trust myself to do something like that. Even with only 18 levels, I'll probably fuck it up.
But anyway, yeah. While we're waiting for that to load, basically, what I did was I solved for every. Oh, here it is.
Just put a water bucket down there, yeah.
All right. So let me pull up the chat just to make sure that I'm not missing any questions. Right. So what I did here is basically I just solved for the value of each coefficient individually. I solved for AF by guessing that y was equal to AF cosine omega ft. And then I just took the derivatives of that, and then I plugged those in, and then I just solved for the value of AF using the by simplifying the problem.
I got that one question right. That would have been at a 64 right now instead of a 58.
Yeah.
Like, if I got one extra point, I'd be at a 61. Like, holy shit, this moves up my.
Oh, for the quiz.
Bro, imagine you're just boring a tunnel to the center of the earth, and then someone drops a bunch of pickaxes on your head because your current one is running out.
Wait, hold on. Who was that? Sorry, I didn't see who was speaking.
Do you want me to just press mute all?
No, it's fine. I was just wondering who it was because I wanted to like answer any questions that they have. Anyway, I digress. I guess it'll be like how many licks does it take to get to the center of a Tootsie Pop? You know, the world will never know. Anyway, so yeah, basically what I did for this, sorry for rambling. I just solved for everything individually, and then I just used the resulting formulas to calculate for each thing. Something that I should note, I can't remember off the top of my head why this works, but wait. Oh yeah, the value for omega f, or omega s, not omega f, is equal to the square root of b. So whatever value you plug in for b, you just square root that, and then that's your value for omega s. Yeah, let me write that actually.
Kill him. For the glory of the nation. I made 4.
Right, so there. So square root of b is omega s. As is equal to v0 over ws. Af is equal to a divided by negative w omega f squared by plus b. Why did I say by? Also one more thing. AC is equal to the initial y value. So yeah. Any questions? Actually, you know what just occurred to me? I'm gonna do what's called a pro gamer move. And I'm gonna screenshot this. And I'm gonna paste it in the GroupMe.
Oh, that's a pretty good idea.
Wow, incredible.
That is a pretty good idea.
Alex, there's 10 cycles left.
So yeah, does anybody in the chat have any questions? MVP, thank you. No, you. I mean, the MVP thing is debatable considering I'm like, thinking about like, dropping out of, well, not dropping out of Rutgers, but like, just like taking leave of absence for one semester. Anyway, I digress. Does anybody have any questions, any confusion as to why or how this works?
I should note that one of the key things to actually get this to work in MATLAB is to you need to use you need to know about first it's a little more basic. You need to know the roots function in MATLAB, which is where it just finds the roots of a value, right? Just take your square roots, whatever, or just roots parentheses, just that. But the more important part is the command to make it find the imaginary. Oh no, I'm sorry. There's no roots. No, I'm sorry. That was stupid. No, the square root would be your you know what I'm saying. Anyway, omega. So once you
Oh, by the way, sorry
your,
to interrupt, but I'm not blocking the screen right now, right?
No, that's fine. It's fine.
Okay, good.
Yeah. So but the most important thing that people are going to need to be able to code this is the MATLAB built-in function to isolate the coefficient of an imaginary variable, and that ends up being, let's see here. Can I annotate over yours or no? Are you able to write that in there?
I'm sorry, what was it?
Are you able to write the imaginary function into for MATLAB, the code to isolate the coefficient of an imaginary value?
Oh yes, I believe it's hold on. Let me pull up my code for it.
Well, no, I know what it is, but are you able to write it in there?
Actually, yeah. I think it's
I can just write it.
Let me pull up my code just to make sure I'm getting it correctly, because I don't want to like accidentally write down something that's incorrect.
Okay. So
I'm gonna stop screen sharing now. Because I think I've already got everything on the screen so far. So I mean that should be praised. I've got everything on the screen so far pasted into the chat. So what are you planning to do? Actually, Bob, tell you what, if you oh wait, that's right. Do you have a GroupMe account, Bob?
Oh yes, I do.
Sorry, not why did you say GroupMe? Do you have a Google Drive account? Sorry, I don't know why I said GroupMe.
Yeah, I do.
Okay, because what I did last time was that I just uploaded the file that Zoom generates to Google Drive, and then you could
then put a link to that in the group chat.
Yeah, that's what I did.
Also, I can do that with the same thing with iCloud, but it doesn't really matter.
Oh, I see. Well, I only suggest the Google Drive because I'm using I use Windows machines, so I'm not familiar with how
it'll just be a link. You click on the link, doesn't matter what machine you're on, it'll just start a download.
Oh, okay. I guess that works, yeah.
And then Google doesn't have your data, and the link expires after I think like 30 days or something.
I see.
Yeah, something like that. A little bit more private, and that's what I usually prefer. But if people have issues with that, I'll do whatever it needs to be. Dropbox, Google Drive, whatever. I'm just not doing Zoom Cloud. We don't need it to be on the school servers.
Yeah.
We don't need them logging our daily activities.
Yeah. Just so you know, it is actually imag, not img. So the command as it exists in my code is.
Oh, did I do a typo there?
Yeah, I thought it was img at first, and then it was, and then MATLAB was like, "Hey, dipshit, that's not what the command is." So.
Yeah, I did do that little typo there. I was even looking at it. Yeah, so if so in this case, roots is your variable name, in the code Victor just put there. So that would just what he's did was his two roots came out to be a vector. So what ended up happening was he put the 2 there to get the positive vector, because MATLAB's always going to list negative first and then positive second when doing like a solve, and it gets a positive negative values for an array. So it's going to order at least the biggest, usually is what it's going to do in that scenario. So because there's only 2 roots, he wrote 2 to give it the positive root. It doesn't remember, it doesn't matter which root you pick, so you can do 1 or whatever, but because his was an array, he specified the 2 there. So this is your normal command for doing so. But also I didn't completely verify his work here with the statement on the formulas there on the omegas, but that might also work just fine, just doing the square root of b. But I did not fact check that one, but I would assume that it would be right. I can look real quick. So that's right. Oh, this. What? So Victor, I'm not really understanding how, like, your looks like you're solving for the so you get it, and oh wait, let me see here. So you get there's does yeah.
What I did
Right.
what
There
I did
will be no way.
isn't really all that complicated. I just took the
There's gonna be no
I
way
just took the
there.
formulas that I got and then just plugged in the input values into the formulas to get the coefficient.
Yeah, so yeah, that does work. I tried to do it more standard to the actually how you would solve it by hand. But in this case, because there's never going to be a coefficient on the y double prime, and there's no y prime term, you're right, this will always simplify out to root b for your omegas. So you can just leave that as positive. Don't worry about positive or negative, because this would already take that into account. So if you just tell it the so that's completely fine. Solution there. Oh no. The roots function. Oh, so the roots function I was referring to wasn't roots parentheses. No, the roots function technically. So if you wanted to take a square root, for example, like that, it's not gonna do your it's not going to find the zeros of the equation, right? Which is what you were more what I was more kind of suggesting before. No, that the square root would be the code for square root would be in this case would be, I'll put it out right in the chat. It'll be right there. That'll be your command is sqrt, and then put the value you wanted the square root in it. And it doesn't have to be a double floating point, could also be symbolic or any other variable. But that's how you get a square root. So if you're doing the omegas, you would end up having your formula being what you're going to write in the MATLAB as omegas equals square root of b. That would be your statement in MATLAB. Now when you do that, it is a very big simplification of the actual process, but that's not what the assignment is. It's not the MATLAB exam. So I mean the DiffyQ exam. But I mean, if you get the right answer, which is this what it does, doesn't actually matter. But anyway, so this is so that omega square root b line right there is going to work for everybody, and that would be a good way to simplify it and not end up with 36 lines of code to have something that does it exactly like how you would do it in class.
Yeah. Sorry to interrupt you, Bob. James, to answer your question, basically, what's going on is that for the first problem, it asks you for a bunch of coefficients that will make the differential equation that they give you work, right? And so the stuff that you're seeing right now, the stuff that I'm sharing, this is all these are the formulas that I got for each of those coefficients. Because what I did was I basically just like, so I solved everything by hand first, and then I just to obtain formulas for each coefficient, and then I just made a program that plugs everything into the formulas to, to get the final result. Let me know if you want me to stop sharing, Bob. By the way, because it just
Oh, no,
occurred to me,
no,
I
it's fine.
accidentally left it on by accident.
So do we have any more general questions on question one? Anybody confused on the variables, the process, or anything about it? So so AF is going to come from your Y particular solution. Do you have enough room here to show? So your AF eventually boils down to what he wrote over here. You can see his work. This is just his statement on what it's going to end up being. But if you looked at the question one, they completely butchered variable naming to an unimaginable extent. I'm not really sure what they thought they were doing with the variable names they provided. Uh, but that's where a lot of the confusion's coming from. It's not that exactly the code or doing it is that difficult. It's more of it's hard to recognize what they're actually suggesting you to do. So if you looked at it, it said your solution should look something of the form, and then gives AC cosine of omegas t plus AS sine of omegas t plus AF cosine of omega ft, if I remember the last one correct, the last part correctly. But the first two terms, it says if you're, it's by it saying that it's your solution should look something of the form. That shows that every time you do this, that your roots are going to be imaginary. And then that's where all of this comes into play, is that you can already assume when you're coding this that it's going to be imaginary. All right. And so one of the first things first thing you're gonna do is you're gonna find AF just like you would in class. Now this AF just ends up being the coefficient you do when you're solving for it is your arbitrary coefficient on Y particular, but they managed to put an A variable, well, not even a variable, it's just the constant they provide, and they put just our normal A on Y particular, on GFT in the question one. And then that ends up creating a lot of confusion because that A there is not actually the variable you're solving for. That's not even a variable. That's going to be an input that you have from the question. So that's not actually what you're even solving for. So that's one of the things that starts happening, is that you get confused. It gets really confusing with these variables. This AF is what you solve for, but the A already on there is not AF. So when you're doing this, it ends up being for when you're if you do this by hand. Let's see if you showed this here. Yeah, you can see from Victor's work right here that oh, you're missing your you forgot to write one of the A's on the Y double prime when you rewrote it. It's a little right. I don't know how to mark that.
Wait, are you talking about me, or did I?
Yeah. So you see that first line after this, like down. Yeah, that line, right? So wait, did you actually? One second. Did that actually? Oh, yeah. No, you know what? That's fine. So this A, you see the A here in front of the cosine on the right side. That's your GFT. That's different from the A over here, and that's not actually the variable you're solving for. That's a given input to everything. Well, to your equation. Now, it doesn't even usually directly even give you the input when you actually try doing this. The way you know that this A input here on GFT, what it is, if it's equal to 0, is that it has to be equal to 0. The only way that cosine can ever equal 0 is, well, unless you had it equal pi over 4, but that doesn't actually happen because t is a variable, so it wouldn't be, in order for it to always equal 0, then a would have to equal 0. So if it gives you the equation, a differential equation, and g of t equals 0, then just set this a input to 0. Now the AF over here is different from the A because that's actually what you're solving for, and that's your arbitrary constant for y particular. Then you go down to doing your solving the for y homogeneous, which also they didn't make terribly clear at the end of the day. But this all you can see from Victor's work here. If this is if you're doing it by hand, and the key is just turning what Victor wrote in this into Matlab code. And one of the things I put in the chat there was a couple different methods you could get your omegas from B. The last one with the square root was the easiest one to do so. But if you wanted to do something a little bit bit more fancy, you can use the imaginary. You can use the you can use the what do you call it? The imaginary function in MATLAB to pull out to pull b away from the I, from your imaginary variable value. Does anyone else have a question on any of this? Like, we can get down to nitty gritty of the actual code a little bit soon, but I just want to make sure everybody's caught up on the conceptual. And by the way, they don't even ask you for your overall solution. They only want AC, AS, omegas, and AF. So you don't even have to put it together into one thing. So if that makes any of this a little easier. Is everybody good with the understanding the process for number 1? Okay, so we're good here. Okay, so we can move on to
Actually, 1 second. Sorry. Sorry. Sorry about that, James. I was busy doing something, so like
And it's like good quality.
I wasn't able to like unmute, but basically like yeah, that's all we need to do. Like once you get all the complicated shit out of the way, you can just like bang this out in like 15 lines of code. It's pretty easy.
Yeah, it does get really easy though. Like I said at the beginning, the hardest part was that they just butchered the variables.
Yeah,
they butchered it really bad.
Yeah,
I mean,
like I agree with you on that. The instructions were unclear. Like I opened this as soon as we got this assignment. Like I opened it up, and it was like looking at fucking cuneiform. Like I had no idea what it was saying. I was like, what the fuck is a standing state frequency? Like what is going on here? So yeah.
I had to ask him what it was right when we started the right when he mentioned that when it was going to be due the first time, which was like a week or two ago, or 2 weeks ago, 2 weeks ago, I believe, is when I stayed after and asked him. But I mean, the wording was so bad. I mean, I don't know why they called it omegas, and I think the reason they called it omegas is because they already used B for this term in front of Y, which I can tell you that this A and B here could have been called anything else. I mean, that would have made that make a little bit more sense there. It's just they just renamed everything to the point where everything's confusing. I mean, I don't even know why they call the initial condition for Y prime. I don't know why they call it VO, V0. I mean, why would you call it that? Can't you just call it dy naught? MATLAB will take that, but you just
Conclusion?
it like V0. Like what does it even come from? I mean, even something so simple as that, they somehow even make that up, make that. I mean, it doesn't make it necessarily unclear, but I mean, that just doesn't help with the overall presentation here. And steady state already includes sine and cosine. I didn't think it did. I can verify that real quick. Steady. Lord. So usually if you look at a sine and cosine function, if you graphed it, your frequency of your wave, right? So if you think of it like if you think about it like if it was actually in motion, right? So if you had like your x and t axis were both the same axis, but I mean, well, let's just say it moved with respect to time in the xy plane, right? As it did that, your frequency of those waves, right, how close they are, would be based off of the coefficient in front of t, which in this case is omegas. So, and that would be a consistent frequency of the waves. Now, maybe for some reason it means something else in Matlab than it does in I mean not Matlab in DiffyQ than it did in I don't know what would that be algebra 1. If they start redefining what a frequency of a sine or cosine function is, then maybe it's something else. But I really don't think they changed what that would be. But if I'm wrong, then somebody can just let me know. And then based off of what the chat was saying, it would probably just end up being the solution. But I really here's the reason I'm very sure that that's all that is because if it said find it, right? If you looked at the assignment, it said I read this wrong tab. Let me go back here. So it just said, I'll read it word for word. Find the steady state frequency of the system, solve the undetermined coefficients of the problems to find the value of AF, solve the initial value problem to get the value of AC and AS. Well, if you notice here, the function header they give you has AC, AS, omegas, and AF as your outputs. Well, if they're telling you to find a steady, if they tell you to find the other two bullet points, tell you to find the other three in the given function header, then find the steady state frequency of the system must be omegas. There's no other way around that because that's all the outputs that they provided. So, and we know that the frequency of a sine or cosine function is going to be the coefficient in front of t here. And they put omegas right here in the form your solution should be in. So I would think that that's you're referring to I see your I know what you're talking about. Yeah, it does it does do that. Okay. Any other questions about one specifically? Or generally, and then I guess we can go in the tech support at that point. Unless somebody has a question about another one of the problems. So we're all good on understanding how simplistic one is, but then they managed to make it nearly impossible to comprehend. I mean, they couldn't have made that any worse. It did take me a couple days just sitting there trying to figure out what exactly are they trying to say, but eventually I put it together. So that was kind of nasty at the end of the day. But so I'm gonna take it. There's no more questions relating to understanding what one was asking. Does everyone want me just to go like one by one through here, explaining like what should be your objectives for each question, like going through like just what we did with one, but like with each one? Oh, okay. Okay. Sounds good. Victor, can you stop sharing the screen?
Sure.
All right. Thank you. Share, rewind. Yeah, that one. Okay. There we go. Okay, so we went through one. It boils down to be incredibly simplistic after yeah, their horrible wording is figured out. And this one, this is just want you to test it, and this is just where you you can test it. You can use this to test your function, but after that, just want you to write a comment that what you got with this. So this isn't really too bad. That's not really a big. You don't actually have to run the code for this besides testing. So then you get to this one. Consider this undampened oscillator equation. So this is where you're going to use your function you just made. So you're just going to do your normal let me see here. You're going to you're just gonna do your normal function. You're gonna do your normal you're just gonna, so in this case they call it undampened second undampened solver, right? Yeah. Okay. So you're gonna use a second undampened solver and put all your inputs in. This is gonna be your B term, right? Yeah. Yeah, there's your B. Your A in this case was 1. And then over here you can snag that right here. So you know that that's going to that's going to be a variable that's going to change, even though that's a constant. So you're going to have, they want you to try these values. Now, one of the things that's going to happen is that this should work for these first 3 values perfectly fine when you do that, when you just run what you have, your function you made up here for 1. Oh, also important note, the format file manages to put number 1 at the very top. So the second you start doing anything after number 1, all of a sudden Matlab has a big error and nothing works after your function for number 1, and you have to move it to the bottom. Unlike the first 2 Matlabs where they're kind enough to put the list the number 1 at the very end of the format file instead of at the beginning. I don't know why they didn't do it in this case, but you will have you won't have a problem until you start putting stuff underneath the end. When you use end. So yeah, you got to move question 1 to the bottom from the format file if you use the format file. Anyway, so you're going to try this. You're going to use these first 3 values into the this differential equation. But what ends up happening is that these first 3 work. This one should result in a 0 by 1 array. And things should, or either should break, you should get no output, just something should not happen with this, and that's what it's asking. Like, right, it's asking what happened with the last solution. So that's kind of like, that's what you're going to answer in the question. What exactly caused, what exactly was the issue? Why was this different Well, what was different? Okay, y is going to happen. The y is number 3 technically. What happened is going to be your thing here. So I'm not going to particularly say exactly what happens specifically, but just know that this is not going to work anything like what these did. So this fourth one is going to have a little glitch there. So this isn't too bad. You're just gonna have your B value is gonna be 9, A is gonna be 1, and then they give you these other two. So you can just keep doing it like that. Just make a mental note that B's here and A's here. So you can do that. So number 3 wants you to do it by hand because that's the only way you can actually know why what happened in 2 happened with omega equals 3. Right, and then you can see they plugged that in here, right? So here's omega equals 3. This is the same thing, but they plugged it in there. So when you do this by hand, you'll see why this doesn't work. Now, when you do this by hand, make sure your guess would be just like the guess that was being shown in Victor's work there. Don't do like A times T times cosine or whatever, right? Don't do that. Just do the raw A times A of F times cosine for your guess. Don't actually don't try putting a T in to make it work. Don't add a sine term and solve for A and B. Just flat out use it because it needs to not work. So in order to show why it didn't work up here. So even though I didn't actually even check to see if you could do it with one of the solutions that he told you, like adding a T in, or multiplying a T in, or adding a sine term or something. I don't know if that actually makes it work, but it's supposed to not work. So you just have to answer why it did not work, why it didn't work by hand, because you couldn't physically see it in the code technically. So that's what happens with 3. Same problem as 2, it's just asking why what happened with the last test value happened. So if you go down to number 4, number 4 is a little bit more as gets a little bit harder than 2 and 3 were a little bit, because now you do have to write actual sum of code here, a little bit more code than what 2 and 3 is just comments purely. You're not actually writing even any code for 3. Now, when you get to number 4, I want you to solve them numerically, but you need to make them into a system of first order. Go ahead. Is there a question? Sorry, I wasn't watching the chat.
That sounded like microphone feedback.
Oh,
I don't think that was anyone speaking.
Oh. Is anybody asking something in the chat? Oh. So. Okay. So how you type them out? Okay. Here's the thing. You're not going to bother typing these out. At least for 2 and 3, you're not going to bother typing them out, because because these have already been considered as this in your function you made in 1. You're literally just putting your input of 9 in for B. You know y not equals 0, b not equals 0, and you're going to test for 2. You're testing. You're going to do the same thing 4 times for each one of these omega F values. These are all omega F. So if you come up here, you don't actually have to type this into Matlab. Yeah. So you just the variables that variable your inputs, right? You just have to put your 5 inputs in. So it gave you what these two were. Omega F was changing you had 4 different values to try for omega F, so you're doing 4 different you're writing this out 4 different times for 2, but your A what was B? B was 9 down here, wasn't it? Your B was 9, and then A was 1. That's all you're doing. You're just getting those 5 values, plugging them in, and you get your answers. And then 3, you're not actually using 1 at all. All you're doing is you're going to do this, you're going to do it by hand, and then but only for omega equals 3, omega f equals 3. So that's the thing with 2 and 3, is that they're pretty much parts of the same question. But don't force 3 to work. Don't make it work. Don't try like a times t times cosine as your guess. Don't do like a times cosine and then plus b times sine or something. Just don't try making it work. Just do it in the most basic form possible, just like the guess that was shown in Victor's work, which is just a times cosine. You need it to fail so you can see why it failed for your function. So that's all you're doing for 3. If I'm going a little too fast, you can let me know. Example of unbounded resonance. So what ends up happening? Okay, so I can just tell you what your end result is when you do this by hand, because it's actually not really a big mystery. You end up getting let's see, right. I actually did it beforehand to have this work written. Or no, that was actually for the quiz, so I'm not gonna say that one. No, that's actually the work for the quiz. We don't. Oh wait, no, it wasn't. wait. Now I need to verify which one was for. Oh, no, that's not the quiz. The quiz was before. I did that before lecture. Okay, so if you did this number 3 by hand, you'll eventually get to the point at which you'll get a statement. Everything will cancel. All your AF terms will cancel, and you end up with 0 equals 1, which is a false statement. So it breaks because because you end up getting you can't solve for A because you get a statement that's just wrong. 0 cannot equal 1. So I don't remember I don't usually remember names for like unbounded resonance, so I'm not sure if that's exactly what unbounded resonance is or not. But in this case, if you were going to force this to go by hand, you would add in you would probably first thing to do is like a times t times cosine as your guess. So then maybe you would eventually go, or maybe you have to do the plus b times sine as your guess or whatever. But no, because there may be there absolutely may be and there could be. I mean, I could probably tell you in about a half a second. Give me 1 second. I mean, I have a I'm just gonna sit here with my TI-89 and tell it to do the question, because it is actually that easy for 89 to do something like that. And I'll tell you if it is actually solvable, but I'm pretty sure that it does eventually have a solution. I'm pretty sure it does end up. I think there's even if it's not computable, like with simple arithmetic, I think you end up getting a y particular out of it. Let me see here. So if you guessed, let's see. I'll just test each one. A times t times cosine of 3 2. Let's see if that does it. So then okay. You end up getting a times. So do this, and then this will be. Oh, that flips to the sign. Okay, so a times t of 3t. Okay, that'll be y prime, y double prime. We don't even care about y prime. This ends up going. Okay, that's gonna go to negative a times sine of 3t. Let me see. And then this goes to. Okay, so then this will go to negative a times sine of 3t plus negative a times t times cosine of 3t Doesn't this simplify? Yeah, it does. Okay, negative 2at. Oh no, sorry, just negative 2a sine of 3t minus at cosine of 3t. Let's see if this actually. You might need to actually do like plus b sine, but I'm pretty sure this ends up working in some way. I wouldn't say there's no solution. I forget what he called it before. Oh, you know what you could say? Because it is asking why didn't your method work properly. So it didn't work properly is because this only allows it only can try the guess you gave it. So because when you do it by hand, you use the same guess, and because the guess that the code physically uses doesn't work, that guess doesn't work in this instance, then your solution didn't work. You didn't get a solution because of that. So yeah, you can just say that the guess that MATLAB had did not work in this particular circumstance as your reason. But I would show the work going through this to get to that a does not equal 1 point. And in MATLAB notation, you say, well, you're not going to write it in code, but I mean, you could just do 0, and then the does not equal to little squiggle thing, and then equal 1. Yeah, you should. No, the reason you're doing it by hand, you can see here on number 3 on the shared screen, it tells you specifically to do this by hand. Because the reason is, it's unclear just by looking at number 2 why your method did not work for omega equals 3. So they wanted you to do it by hand so you could see what happened. So that's why you're trying to guess that the same guess that MATLAB uses to see why. So it ends up being at the end, your method that it's the word it says right here, your method, referring to your function here, doesn't work because the guess doesn't work. It would need a different guess to be able to do it. Maybe it works with AT. I didn't want to waste the time trying to put multiplying it the guess with a t to see if that made it work or not. You might have to add like a b cosine thing. I don't know what the exact thing, but it likely has a way to be solved by hand. Even so, what you're doing though is you're showing that the guess number 2 uses that what your function uses does not work in this scenario. And that's your reason that your method, which is your function, did not work. But you got to show the work on how that happened and explain like how the function can only do the guess. It only works with the guess that you programmed it to do. So in this case, the guess did not work. So if you're doing this by hand, your guess would not have worked. But then you might try something like a times cosine, and then plus a b times sine term to see if you could get a y particular. So it's not necessarily that you can solve it by hand or not, but the bigger thing in this case is that the method, right? That's all it's asking. Why didn't your method, which refers to the method up here, right? It says, so first we will write a method. It's referring to your function header, your function from 1. So you just got to explain why this didn't work, not that it's unsolvable, because that's not necessarily true. He may have made it purposely impossible to solve by hand, but technically solvable just to force a bad answer out, right? Because if you say that it is not solvable at all, then you hit the point where, oh, actually it is solvable, because number 4, yeah, that's right. Number 4 uses the same thing. Yes, number 4 does establish that it ends up being solvable. So if anybody has it, I think we can move on to number 4, unless somebody has a question. I'll watch the chat if there's a question on 2 and 3 at this point. But number 4, they tell you to use this help page. Now, this link for me came back and said does not exist. Now, I don't know if that applied to anybody else, but no, I didn't find this. I don't even really this page I didn't even find by like Googling for this. So I didn't even exactly find this exact page anyway. You get to the symbolic toolbox stuff there, or even the symbolic help page, and it doesn't actually I didn't find the specific URL. Now maybe somebody else's URL decided that it wanted to work. I don't think so, but it does work for you. Okay, for number 4 it does. Oh no, I'm sorry. It was number 5. I'm sorry. It was number 5 that did not work. Yeah, that's right. I'm sorry. It was number 5. This one. If I click this, yeah. See, this page you're looking for does not exist. And you get to just symbolic map toolbox. Yeah, you are right. Yeah, number 4 does work. Number 5, this one did not work for me. Now this one might work for somebody else. I don't know. But I don't know why this didn't exactly. Now my guess that what this was maybe using some. I mean, it's unclear what this exactly was referring, because if you got to this page and you try to like going through the functions, you don't exactly find what you're looking for, right? Like you can see like create, like this is okay, but these aren't really I mean, it's hard to find the exact page they were referring to, because I personally did not find the exact one. But anyway, so number 4, the help page is really, really helpful on that. I mean, the code ends up not being really too bad for number 4. So if you look, help page does do a pretty good job explaining this, right? Using the Matlab function as a good way to get this into a function handle type of thing and all that stuff. So one thing I learned was that finding necessary like functions built into Matlab is pretty easy just by just using this help center. And that's how you find a lot of these things that you don't actually know, that nobody's ever taught in like the intro to computers course or whatever. So anyways, number 4 specifically. So this talking about converting it to a system. So you can use the help page to be able to do that. And then you get, and because now you're going to prove that you can solve this with MATLAB by using a different method. So it ends up being the same thing. I believe from this point on, you do not use your function again. I'm pretty sure that all this time to get this whole thing figured out and then write it ended up being not a big part, because these were really, this is the only one you even ran it for, I believe, at the end. This one said, yeah, this one you can use it for number 6 if you want. Down here it says you can use it if you want for number 6, but number 7, it will not work for number 7. I did try. It does not work. Same issue that happens with that mega equals 3 for from the first half. It will not work. I think it works on A but not B is what ends up happening. So this one is going to have to use your symbolic one, which is the one established in number 5 over here. Anyway, so so the key here is that you want to separate them. I mean, both these help pages, well, this help page walks you through it. This one probably do the same if it opens. Now, this one never actually got me to the place I was trying to get to. I never even really found this URL anywhere. But anyway, so 4 seems pretty, this link is pretty helpful, and you should be able to get through this pretty easily. And then you're just going to do your plot, just like we've done in previous MATLABs. And you're also going to want you to plot your solution from the previous part, which they're referring to they're referring to your solution from let's see, it's referring to your solution that came out from omega equals 3 on number 2. Well, the thing is, because they did not ask for your overall equation that would have popped out of your function you made for 1, you're gonna have to piecemeal it together to for number 4. So what you're gonna end up doing is but the thing is, they already established what it equals, right? So if you say like function 1, like let's call function 1, like you say f1 equals and then just establish only one variable. So open parentheses t, close parentheses, open parentheses, and then you do this right here. Because so you should I forget what variables you don't get out of 2 when it breaks, but you should be able to get your MATLAB should tell you which variables you get out of here, and then you should be able just to state that as a function, and then use fplot to plot that. I believe that's what I ended up doing. I can double check over here to verify that that's what I ended up doing at the end. Let me see here. So that ends up doing. Okay. It ends up. I believe that's it. Yes, that's there. Okay. Yeah. So yeah, because they want you to plot this and your solution from the previous part on the same axis. So they want to know how when it breaks on 2, what the difference is between 2 and 4. 4 omega equals 3. So you should see what you can plug in, and your outputs are going to get you what you want for this, and you can just use this as your function, as a function of t, and use that plot. Be able to do that, but it will break. I'm not going to exactly specify where per se. I don't want to like give away exact answers for the entire thing. I don't want to say what like specifically if they match or not. You're supposed to kind of like you're supposed to do it yourself. So I'm not gonna like go specifically in this stuff like do they match or not. But yeah, that'll be your strategy for 4. I assume nobody has any questions on 4. Is that I can just move on to number 5, and then I'll look back if there's a question for 4, I guess. I think that's what I'll do. Okay, so if you go to number 5, number 5 wants you to pretty much do the same thing out of 4, but now this time, instead of doing it numerically like this link that does work establishes, you can do it using symbolically. Now using what? Now I did eventually find the page that did show this. Wasn't this link? Let me see. Did I leave that open at all? Is that this one over here? Is that this? Yeah, I think this is it. You end up. I think that the page ended up be calling oid the vector field is what the big one you needed was this. There. I don't know what page the link was. Oh, 4. So 4 wants you to use to write the code. Write the code to solve the second differential equation numerically, which you can find how to do from this link right here that they give you, which does work, unlike this one, unlike the one from 5. And when you solve it numerically, it does give you do get your it does not break, and it does work. And then what it wants you to do is it wants you to piecemeal together the outputs you got from doing it with your function with them, because now if you look, it's the same differential equation for 2, 3, and 4. Only difference with 2 is that it has you try a couple different ones, but it wants omega equals 3 out of 2. So you might want to like have it save this as a separate data set, so you don't have to tell it to do this all over again to get your outputs again. But that's usually actually oh, you know what? Because if you do this, if you tell it to do this last for number 2, you don't even need to say, you don't even need to do that. You could have them listed separately, but I mean, you probably would anyway. But because this is you don't run code, you don't actually run code on number 3. So okay. Anyway, so when you do this, shove it numerically, which is the method established over at this link, and I mean it's pretty.
How do you misclick?
What?
My bad. Playing Friends with Among Us. Playing Among Us with friends.
Is there a question? No. Oh, so 4 ends up wanting you to take what you did get out of omega equals 3 with your function, and plot that alongside the plot that with this. So just your normal like f plot and stuff for your original outputs, because it does give you the format, right? On number 1, it give you the format. So you take your outputs and then you get your function. Well, it depends how not quiver plots. No. Fplot is a Matlab function. So if you tell Matlab, so that's different than a data set, right? It's a little bit different from a data. Like if you told, like plot normally just does points, but you get a line when you use Fplot. So that's like when you remember on Matlab 1 when you first had to do F equals at symbol, and then you put in the first set of parentheses you put like what was the function of, so like t, and then immediately you did another set of parentheses to write your function in. Well, in that case, that'll be this, and the outputs you put in would be the outputs you got out of 2. Well, when these outputs start breaking, that's why you got to have the variable saved this so it uses the broken output, so you can see what happens to the graph, to the figure, right? That's what you're supposed to see. You're supposed to see that it looks bad because not all of these might have numerical outputs per se. I'm not going to exactly be more specific than that at this moment, but when you do it with omega equals 3, this is not going to work, and then that's why you establish why it didn't work in 3. Then you're going to show that Matlab can do it. Anyway, so fplot. I don't know why that fplot hasn't been a thing yet in this and DiffyQ yet. I have no idea why not. But that does draw a line and it gives infinitely many points along the line versus like plot, which just graphs us a data set. So not quiver plots, no. Not that you couldn't. Well, I mean, yeah. Don't use quiver plots because it does want you to see what the difference the solution looks like when when it's broken like this, right? So it's almost like if you try plotting it, if you didn't want to actually try another guess for what for finding the particular solution, and you just wanted to just like give up on that. It's kind of like what would that look like visually if you just gave up on trying a different guess for finding my particular. So yeah, you're just gonna use fplot to get that. Not quiver, not plot. Just use fplot. That's gonna be the easiest way to do it. Because that draws a line versus plotting. Just instead of marking data points, like plot does. You just have to use your normal your normal function state. Your function define a function, and you can that'll be your really just define this as a function there. Anyway. So that's what 4 is. If anybody has more questions on that, we can come back to I'll answer them. But I will go into 5 now to keep this rolling a little bit because I do want to have time towards the end to do any technical questions with people's specific code, just in case, or if anybody has or if anybody has something a little bit more specific or anything along those lines. So when you get to 5, MATLAB can this one wants you to do the same exact thing you did before, but except you don't need to graph it. What you're looking for is do you get the same you get the same answer, which is what you're looking for as your 4 outputs. Now, but you know what? That ends up being you actually have to graph it. Because this method in 4 doesn't give you can't define a function that way. Oh no, yeah it does. No, I'm sorry, I'm being stupid. So you can do you can just compare them. You don't actually have to plot it for 5. I mean you can, but now this link is broken for me at least. I did find what you essentially need at the end of the day, and that's going to be this is going to be a big thing. Is OID to vector field is going to be important. Now there is a lot of overlap between 4 and 5. It is pretty much doing the same thing. The 4 was doing numerically. This is doing symbolically. I mean, OID to vector field would separate. Actually, this might have been what I used for the other one. Oh, Victor, do you remember if this was the one, what you used for the 4, or was this 5? Was this symbolic or numerically here?
I think I used ode to vector field in question 4 because I never progressed past problem 4. There was a problem in my approach that I wasn't able to fix.
Oh.
So I haven't
okay.
I haven't been able to fix it yet. So my stuff isn't complete. It doesn't do the entire thing.
Oh. Okay. So, but your 4 worked, right? So that. Okay.
I think partially at least. I'm not sure if it worked all the way. I don't remember.
Okay. Yeah. So one of the things I did, I had to establish something a little more generic in terms of what I'm looking at while I'm going through walking everybody through this, because the way I did it was that I had pretty much my function do the entire lab. I already had it do like have an output solution, and I had it take care of things like later on you get to the point where you do have it's not that one, number 7, yeah. Here you do get a y prime term, and then your function doesn't work. But I mean, I made it work for A with my function by just giving it by just adding another variable input, but it ends up that does, and you can do that with yours as the way you established it before. I mean, you have to rewrite the equations that were provided to make it allow it to do that. I did ask Professor Menke if you were allowed to increase the number of inputs and outputs out of your function from the given inputs and outputs, and I ended up doing that. I ended up adding a lot of input out. Ended up adding an input and an output to make the whole lab do it faster. But what I ended up doing was that ended up quadrupling the length and difficulty of coding your function. I would not recommend doing that, and this does tell you to do the symbolic solving method from 5 anyway. 6 you can still use your function, but anyway, back to 5. So 5 establishes a symbolic function method. Now this link doesn't work for me for whatever reason. I don't know if it works for anybody else or not, but I tried. Let me see, where was that tab? I tried leaving these all open from when I did this. And oh yeah, and here was the one where I found how to find imaginary part of a complex number. Nope, that's unrelated. Oh yeah, this was a big thing for when I was doing it, the trying to condense the whole lab into to work with just the function you make. Yeah, don't get into this. Don't get into any of this right here. it gets a little bit ridiculous. What was this? Was this one symbolically? I'm trying to find the tab I use because I do want to give you the link in the chat. You know, I'll also put the link in the GroupMe as well. Once I find the tab this one was on. Not this one. No, now this one is helpful because you can convert. You can make something to a function handle like this, and this is useful for number 4, and actually you do have to use it for number 4 anyway. So that wasn't what I was gonna, and I already said no, not always the vector. Where did this one go? Maybe another window here. Let's see here. Nope, not that one. Let's see this one. Nope, not that one. More. When you have 4 monitors, you end up with 5,000 tabs open. That's one of the things. Let's get rid of that. Okay, we don't need this many windows anyway. Okay. Maybe it ended up getting closed at some point. Does anybody's link actually work for number 5? Or does it always go to the same place mine went to? I'm just wondering, because if everybody has that same issue when they click on that link from 5, both do work. Okay. So both links do work for you. Okay. So I don't know why when I click this, I end up at yeah, you can see what I end up at. I just get the page you're looking for does not exist. Okay, yeah. So some people say it does. That's what it says. Other people say it doesn't work. Maybe if I let me see here. What if I try copy and pasting, but not the hyperlink per se, but the actual text? Yeah, that's weird. Some people the link is broken, and other people it's not. I mean that's goofy. I mean, what if I try copy and paste, but not copying the link, though, just normal copy? Let's see. What if I try that? Yeah, that didn't do it. That's weird. That is weird. Yeah, no matter how I do it, I never get there. Now let's see. How did I find it before? I think what I ended up doing, because if I can get the actual working link maybe and put it in the chat, that might help out a lot of people. So if I can not, okay, fine, whatever. Go here. Let me do. Yeah, so 5, you're gonna do the same thing as number 4, just show the difference between the previous way, right? So number 4, you did it numerically, and you're showing the difference between your method, which was analytically, and then number 5, you're doing it symbolically. Let me see. Let me see if I can get this page to actually Matlab. Let me just solve a single differential equation. Let me see if this ends up getting me somewhere. To a single PDE. Yes, this does. No, that does not look right. Yeah, I don't know why that would be so weird like that. Huh. Whatever. Yeah, so I don't know how to get through that. I would really want to give people a solid way to actually get to that page. I even just tried like searching like this the part of the link that would be called, and I didn't actually, you don't find it that way either. Oh wait, for people that did load, what did they call it? Like what was the actual title? Oh sorry. What was the actual title of the help page it was? Oh, for people who the link did work. Oh, Victor, did your link work at all for number 5? Solve different. Okay. Interesting. Oh, you didn't try it. Okay. Interesting. Okay. So, and does this look right? Let me see here. Yes, yeah, okay, yeah, this works. Yep. Yeah, that's the page. That's the right page. And it does walk you through step by step on yeah. Yeah, this does end up working exactly how you want it to. it tells you to do it first order, which is normal owed stuff, and then it gets to second order with initial conditions. So yeah, okay. Yeah, so it's just called solid differential equation. I mean, what's the URL there? Oh. Oh, so the difference between two URLs was the hashtag F1-11214. That's the only part that was actually different. Here, I'm gonna put the link in the chat just to make sure everybody can see if that ends up working for people a little bit better. But yeah, so you're just gonna just compare it to number 4, same thing, and yeah. Yeah, so this is the right page. Thank you, whoever said where it was. Now I don't know how I ended up closing that tab. I tried to keep those all open. Anyway, so if anybody has questions specifically on 5, or anything on that page now that everybody should be able to get to it, I'll answer those. Are we good on number 5? Oh, and also if anybody has like a specific coding issue, like between like now and I know a lot of people have it due 10:59 tomorrow. You can direct message me. Oh, the actual yeah, absolutely. Yeah, I can do that. That'll be fine. Yeah, I can do that. Yeah, I can go through some actual examples through this, but that link for 5 works for everybody. Um, oh no, that's fine, Victor. Very helpful. No one's even expecting you to show up. Just an idea I had because I know you had some nice images to share there. So we're uh, sorry, I'm answering other messages in the chat real quick. Okay. Okay. 1 second. It should be. Let's see where these go. So, my, 1 second. Let me see here. What is this? Okay. Okay. So I think we're probably squared away there, at least for now, with that inquiry. So that's 5. I assume the link works for everyone. I put in the chat there for number 5. I assume that that works for the people that this one didn't. Oh, good. Good. That's good. That's good. Also, if there's like, if a lot of people want like help with their individual code, tonight, by Victor, being here, like, breakout rooms, might be a little bit helpful for doing it a little bit quicker too. So we could, do more sharing that way, if we needed to. So number 6. So number 6 wants you to look at this monstrosity. I'm calling it the monstrosity because that just is ugly. Anyway, so they're going to give you the frequency here, and this is going to be your omega F, is what this is. I really wish they would be consistent with the names on this. Really wish that they would call this for what it was, but whatever. So they give you your all your initial stuff. So you can use the second order solver, which is referring to what you do from this help page that I put in the group, fixed link in the group chat that wasn't actually broken. But or you can use your one you made in question 1 for number 7. So you can use either. So they could give you 3 different test values for omega F. Now apparently a lot of stuff is dependent on omega F. Okay. Another little inquiry. Anyway, so you just so you end up just plotting it. I would use fsolve again. To make things. I'm sorry. Fplot, not fsolve. Ignore that. Fplot to get these to plot. Makes it a little bit easier to interpret. A little bit easier coding too. It works pretty much the same way as plot does, except that you can pretty much. I think it's actually the same input arguments entirely. I don't remember exactly off the top of my head, but I think it's the same entirely. Difference is you're inputting a function instead of a data set. I believe they're the same, but I mean you can look it up, and also it tells you as you type it in anyway. But so once you see what you see in the solution, so that's your comment. Not too bad, right? You can use your line space. I mean, they give you stuff. This isn't none of these are really that bad after one has been decoded. Really, I mean, these 2 help pages pretty much spell this out for those 2. So this shouldn't be too bad. A MATLAB function's helpful for getting like somebody asked me about how you notate a second order differential equation in MATLAB. Well, one of the things you can use is MATLAB function, which is very helpful. I believe there's a link to it in the number from the link in 4. What I can do is put the link to yeah, here it is. I can put the link to the MATLAB function page too if you want to see that. But this ends up you can see here it just ends up taking like this and turning it into a function handle. It's helpful for that. But here, let me put the link into the group chat for that page. I mean, you could probably find it pretty easily on your own, but I'm trying to make it as easy as possible. So, wait, no, I did not. Okay, back up. Okay, I think that was not too bad. I mean, this isn't that bad. This requires you to do it symbolically, which is the same method you used in 5 to do these 2. And then once you plot again, probably end up using fsolve is usually one of the easier ways to plot lines then, because plot doesn't actually make it a solid line, like it'll just put points you get anyway. Anyway, so this isn't that bad. This really isn't bad once you get by one. I mean, everything is pretty not really that bad. So if anybody has any questions on this part, I'll answer those now. And if not, I can do like a little bit of a walkthrough through some of these questions in terms of the coding. I'll walk through code in Matlab. So that's no questions there. Oh, okay. Oh, here's what so what I'll do for you, can't here's what we're gonna do. Yeah. Okay. Hopefully that's okay. I think that's the easiest way to answer that. Okay. So what? Let me change stop share there, and let me change what I'm sharing. Let me change this to the Matlab window here. Matlab. There we go. Okay. So now you can see, I'll just do a quick little walkthrough here. We'll just use the formulas established in the from Victor's sheet there, since that's in the group chat already. Just quick little statement. So once you so we do that, and then let's see here. I'm just gonna use exactly what he uses in the group chat for consistency, and so it doesn't match what either of us already did either. I see here. Okay, there we go. Rotate. Does it not do that? Okay, whatever. Doesn't matter. So the things you know is that let me see here. Okay. Okay, there we go. All right. So in the group chat, he shows he gives the statements on what you're finding here. And so some of these are just literally typed out. So like AF is one of them. So like AF divided by the quantity negative. I'm gonna separate down. I like separating the negative when I'm gonna square something that says yeah, it's mega. That's mega F. Okay, mega F. squared close plus b. So that's the quite literal statement that Victor put into the group chat on his sheet. So that's already one of your values found. Just that easily. I mean, this function really isn't bad once you get to the to the nitty gritty of this here. So the next thing okay, so if you want to find omegas, well, omegas ends up equaling in this case, omegas is for this, because of the givens we know about how simplistic this is going to simply equal square root of b right here, and that'll be that. So there's two of them. I mean, this isn't really too bad. And, AC eventually boils down to just that. And then AS boils down to V naught divided by omega. There we go. And then that's pretty much, yeah, I believe that's everything you need for that function. I believe so. That's right, Victor, correct? I got all the boxes checked off there. A lot shorter than either of ours, to be honest.
I mean, like the you're asking for one, right?
Yeah, but I mean, this is a lot shorter than either of ours, but this kind of checks all the boxes here, right?
Yeah, because it looks all right to me.
Because those are the 4 statements you get to on your formula sheet that you put in the group chat. So
yeah, I think we should be okay.
Yeah. Okay. Yeah. All right. So anyway, so once you establish it, now the first thing that's gonna be kind of annoying is after you do this, you're gonna get to the point that the format file is now not nice this time because they didn't put the 1 at the bottom. So if you try typing anything after here, it's not gonna let you do anything. So that is something to note there. But anyway, so we can zoom through this at this point. So if you, at this point, I mean, like 2 is really easy, right? You can just do, it's just gonna be like, you can just, it's really, I mean, this is pretty simple. I'm only gonna do 1 test out of, okay, here's what I'll have my own numbers for 2. I'll do a different omega value than the 4 there, just to not show any of the, what anything is going to happen at the exact moment. I'll just change what omegas equals there. Yeah, I think that's what I'll do. Just give it a little bit of similarity, but not too much. That's a good idea. Okay. AS omega comma. I mean, this ends up boiling down to be a pretty simple exercise. Okay, B they said was 9. I mean, this is just plugging and chugging. And then A1, omegas is omega F. So I'm gonna use a random number for omega because I don't want to actually use one of the values that's important to the problem. Because I don't want to like give answers away. So that's omega, and then what was left here? We got and those are both zeros. So and then I mean that's really all it takes to get an output out of 2, and you're just going to do that for the 4 omegas there. I mean, not really a big deal. And then 3 is just comments showing the work for 2, right? I mean, so this ends up just being just stupid. Okay, so this ends up just being your I'm just gonna write comments. Okay, so there's that. I mean, this is like really simple to blow through. Now I'm gonna go to where the some of the questions were for some of the code. Not gonna spend time on where there wasn't really questions. So number four uses, okay, here, that's, let me see here. We did, okay. You're gonna just using void to vector. So you're gonna end up using, I believe we end up using SYMS. I mean, you're just gonna use the walkthroughs on these articles. Oh, you know what I'm gonna do? Yeah, just use the walkthrough for a number four, because I mean, it'll walk you through it entirely. I don't want to like do all the entire lab here. For necessary, if I don't really, I'm not gonna really want to type out all the code over again. But we did have a question on 4, and that was that how you were supposed to compare what happens when you do the code for 4 versus what happens with number compare it with what happened when it broke on number 2, which is why I did want to write a function statement. Well, what I did want output values out of 2 just to do that. So what you end up doing, this is why I didn't want to, this is why I did have to put something down for 2. The easiest way to do this is to define a function, right? Because your goal here is to compare the plots. But your function broke, so there's questions on how one actually does that. So you would do this, right? That's your standard function thing. But then you look at 1, and it says your solution to your differential equation will be of the form AC, it just says the whole thing now. That's all you're going to do is you take these outputs from here, and then you just have it automatically plug them in. So regardless of what you see happens with the outputs from the one that breaks on number 2, this will work. So then you get here plus okay. Yeah, so that would draw the values down. What is doing? Sure. I didn't think I needed it. Now it disagrees with me. What is your issue? Oh, I missed the parentheses. That's why. Oh yeah, because I closed that parenthesis. Okay, there you go. All right. So one of the things you can do now, I do find the Matlab help page is incredibly helpful. So if you weren't entirely sure how to use fsolve, you just type in Google Matlab fsolve, and then just click on the help bar, whatever the thing. Anyway, where did the thing? Oh, someone has a chat message. I gotta put the chat on a different screen. What happens here? For the last. Oh, yes. Thank you. Good catch. Yes, that is right. It is omegas for the last one. This one right here. This is omega f. Yeah, that's right. Thank you for catching that. That is correct. All right. Anyway, yeah. So fsolve ends up working. So like if you wait. Okay, there. Figure. I'm gonna call it figure 1. Oh, because you're gonna do the. You might want to do the other figure first. You would say figure 1. Hold on, and then f solve f and oh no, that's not f. I'm sorry, not f solve. I'm sorry, not f. Wrong words. F plot is the word. I don't know why I said f solve. And then stupid. There. All right, and then so you're just gonna you put your work with work symbolic sorry, not symbol. That would be numerical is for. Numerical solve. Okay. Anyway, just normal stuff. So that's how you would get your direct output. That's how you get your broken outputs out of 2 to go into to make portion of the plot, regardless of what occurs. So that should answer some questions in regards to that. Number 5 again. I mean that walks you through pretty easily on the article. You get to this is it. Yeah, this is it. I don't have the exact, but I mean it's like word for word copying the Matlab website on this. Wait. Okay, that's I mean number 5 is not really wait, no, it's number 5, right? Yeah. I mean Matlab just literally spells this out word for I can I mean it's as simple as here, let me just this is the exact text that Matlab has on their website. So we're not going to have any questions about giving away answers here. This is literally a copy and paste of that. So I mean, it'll probably be a function. This probably all be a T technically in this case, but it doesn't actually matter. And in this case, this is just going to be your being Y naught, V naught. And then this is by creating symbolic function. Okay. All right. So second is the second diff void. Okay. All right, and this would have been differential equation of this ended up being, what did this do? This ends up being solve ode for y, and there we go. And then there's the last piece. So then here's the other piece that you're going to need. I'm just copying and pasting this literally from the Matlab website here. So just show the spaces being filled. That's funny. Matlab website didn't have the semicolon there. So anyway, that would be T technically. Any questions there? You're saying I didn't I didn't I didn't put the numerical solve because it seemed for number 4, I mean here, let me mark these. This was this was symbolic solve. All right. Yeah, so I didn't put it for 4, but if people want me to show it for 4, I mean, I'm just showing here with 5 that this is literally, this is me just copy and pasting what Matlab had, well, I mean, what the Matlab website has. So Y solution, I mean, actually, you probably don't even need Y solution. Oh. Yeah, so then you could take this function of P, this actually ends up being a function of should be a function of X. I believe this ends up being a function of, function of T. So when you go to plot it did say to plot it, right? That's what the thing said. Come up with try some plot. You don't need to try some find the answer. One of the things about 5 is that it doesn't work immediately. So you're gonna have to like simplify. You're gonna have to simplify your answer, which is what Matlab already did for you. The Matlab website already did for you. So you don't actually need to try it without simplifying. But yeah, so that this ends up working, and you know you can I do think it said to does it say to compare? See if you get the same answer. That's right. So it does want you to compare it. So when you do this, you can either compare like the solution that you get from 4 to the solution that comes out of 5, which might be the easiest way to do that. Or you could still compare plots too if you wanted to. But do people actually want me to do 4? I mean, this is just copy and pasting junk out of the Matlab website. It shouldn't be too difficult to do, but if people want to see 4, I'll show it. No? Alright. So so I think this checks off 5 sufficiently. Wait, is it still it's still showing the thing, right? Yeah, okay. Where are we? Okay, so that was 5. Number 6. Number 6 you can do with your own function that you defined. If you want. So if you do that, or you can use a second order solver if you want. But I mean, you get your 3W values. This is more. You can also do it symbolically. Number 6 can be done. Wait, what? It glitched because I slid it to a different screen at some point. 1 second. Happy I asked. It did look like it was looking a little odd. All right, did that fix it? Okay, good. Yeah, that's weird. Apparently, Zoom doesn't like it if you switch the window that you're sharing to a different window. Anyway, so where did it start doing that? At what point? Like, at what point did that start happening? Did anybody miss anything that I typed here? Oh, wait a second. All right, take that as everybody can see that fine. And after okay. So I mean, does anybody want to see 6? You can do this any of the 3 methods that were shown so far. And it does give you the other. I mean, it does give you t-vals and the line spacing specifically to do, and other code. I mean, this one 6 is worded a lot better. But does anybody want to see 6? Let me say actually, I'm not entirely sure it works with the numeric method or not. Which was, yes. All right. But I mean, did I spell symbolically right? I probably botched that spelling. No, oh, somehow I don't think I did. No. I think you can. Yeah, that's fine. But I mean, even the assignment like gives you some freebie code too. I mean, that's given in the assignment. So we're good here on the work. People don't need me to walk through 6. If anyone wants me to go back to 6 or show the actual working through number 4, I can. Okay. Now I'll run through 6. So so it gives you everything, and then it says chosen frequency, which is omega f. And that's what the W is. I wish they'd be consistent, but they do define 3 different W's, omega F's to try. Now, I did not try it with the own solver, but I think I'll just do it that way. Okay, yeah, let's to make it, and then okay. I think it'll probably be easiest to do it that way. Okay. So I'll be. What was first up? This is what's the order here? Okay, thanks. AC2, AS 2, omegas, AF close equals second undamped solver, and then you're gonna use the B in let's go back in. Okay. Oh wait, and you mark that 2, 2. Okay. Where did this go? Okay. All right, so your B is gonna be 2400 squared. So can you do it on whatever? 2400 squared. Your A in this case. Now A is a little goofy. Oh, you know what I'm gonna do? Here's what we're gonna do. You can just do it this way and make sure this B equals 2400 squared. Let's do it that way. Call this B2. Then just do it. Yeah, this is probably an easier way to state stuff. And then A depends on what on the W you're trying, but in general, your A is going to equal. So I'm gonna call it A here because this is gonna be in general. It's gonna equal 2400 minus omega. That's omega F, comma, not comma, close times 2400 times cosine of omega F times T. Now, I don't remember, I believe if you don't have omega F already inputted into the A there, before it goes into the function, it will not do it just because you might have said like on the if you do it on the previous line, it might actually omega F equals sorry, not yeah, let's go. Yeah, oh yeah, omega F equals I don't know, just random, I don't know, 3000. I'm not sure if it auto plugs it in or not. If you, I think the order matters there a little bit, but I don't think it will just do that. I forget exact. I did mess with it a little bit to see what happens, but anyway, it's supposed to be your A2. I know I didn't call the previous line A2 because I was just saying generically, so that was just being a little bit generic there. But next was omega F, which was that. So omega F. Yeah, I could go look at my code to see if I see a stating omega F before that worked the way it was supposed to, but then I don't want to show that. So, so I'm not going to. But I'm 99.9% sure on that, and if not, Victor can correct me. Then it said that both why not and why crime not are going to be 0 there. Okay. Anyway, so then you go there. So you can do that for all of them, right? So you can run through the next. I believe there's how many omegas given? 3. So Omega uncalled Omega 3 and Omega 4 there. Just to mark that repeats, and that point, then what you can do is then you can do something like you can do more of your function headers, like what we did up here, right? With this, you can just do this all over again. Like this line, you can use this to get it to apply, and you can just do this whole type of thing again for number 6. So you can just do this, except this time you're going to have a lot more things you're plotting in this one. So that's something. So, but anyway, you're just going to, and this would be figure 2 at this point, and that would go away. Anyway, so this is what ends up 6 looks like. So you just, I didn't specify an A number. I didn't call it A2 because I wasn't using a specific value from there, from the problem. I don't want to like actually write the entire code out. I'm just showing you like the steps here. So this would end up being A2 for whatever the first, and this would be a mega F2 actually. There. Anyway, but what would happen is that, and then of course that would be mega F2. This would be AF2 omegas to AS2 omegas to AC2. Okay. Yeah, so then you end up just doing this this needs to I believe this goes on the prior line to hold off. I believe so. I believe that goes prior here. So hold off. Okay. These 2 lines are exact. These are what they give you on the thing. Yeah, it says if you have an autonomous equation f of t, that is the solution you can use, of course. Oh wait, sound. What does that do? Does that actually just shortcut the entire thing? Does it actually? And now I'm curious. Does that actually create a giant shortcut? Does that actually? I'm really curious now. Does this act? What does this do? Sample frequency fs. Oh. No, someone's asking the GroupMe something. Okay, yes. Okay. Does this actually do this? No, I don't. I really don't think so. I don't really know what they're referring to with that sound statement exactly. What are they saying here? Make it says it may be helpful. It is literally making Matlab output a sound is what it's doing. It says to make other comments, it may be helpful to hear what these solutions sound like. To do that, have an autonomous function f of t that is okay. Yes, that's just helpful for making comments. So this is f2 of t. Anyway, so yeah, you could physically hear this. Yeah, I didn't even do that because I ignored it. But anyway, so here, let me mark this now. So if you do this, repeat for remaining omega f values. There you go. All right. Oh, and you can also to make the lines clearer, you can do spec on this. Wait, let me grab that. I forget the line spec notation. Let me see here. The font f plot notation. F plot Matlab. Make it that. Let me, because if you want to change the colors and make it clearer, you can do that. Okay, what's your inputs here? So line spec. Okay. Okay, it is the next place, so we're just gonna check that. So you can do dash. Okay, yeah. So like if you wanted to be like what was it? Blue, you could do like dash B there, or like black would be dash K. So that's your, that actually has different notation than the plot function in MATLAB. Surprisingly. For whatever reason. Anyway, so is there any more questions on 6? Like you're just gonna do that all the way through. This isn't really too bad. Any questions on 6? Repeat. Okay. Does that all look good, everyone? Okay. So I'll move on to 7. It's the last one. This one does need to be done symbolically, which is gonna be more copy and pasting. I mean, really not to. You actually have 2 different ones you're supposed to do. It wants to know. It does want you to plot them again. Oh, actually, they didn't have you plot them symbolically here. Interesting. Copy. So I'll just show 7, and then I guess we can just go into general questions here. So we do that. And then we go do okay, and then we can do hold on figure, what was it, 3? Figure hold on, and then it's gonna be f plot, and this will be y solution. I mean, if you want to notate this one as a black, and then do the next one, which is gonna be f plot y solution. Let's see here, it's in the color. Let's do it red. And then you could do. It doesn't give line specs, so that doesn't actually. Okay, I think you say hold off on. At that point, oh, and you gotta okay, so repeat for equate for diff eq okay, and then and now it'll be a 2 then. So then that's I'm pretty sure that's all of 7 at that point. Oh, and then of course yeah. Oh, I never said what this part was, did I? But what this equals. Oh yeah, so this is your steady state this is your I believe this is omega f right here. Let me double check that. Let me go down here. So this is okay, so dq so given okay. Oh, okay. Oh, I see. Oh, that's interesting. Okay, there you go. Okay, so so what this is gonna end up doing is that this 2 here is gonna be the 2 should be. I just want to verify something before I say something. That would be okay. Yeah. Okay, that 2 should be omega F there. Yeah. All right. This is gonna be omega F. This is now omega F. This is A, and well, the A given there that, and then this is gonna be minus one. Okay, but it's gonna have the B here. Okay, there you go. So there's all the proper notation for that. And here, let me take this line and put it up top there. Up here, where was that? Here. Okay. 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 Does anybody have any questions now? I think we got through the whole thing at this point. Any questions? Is there any program for one besides? There can be if you want it to. I mean, I made my function one do pretty much the whole lab because Menke told me I could. Now I don't know about the other professor, if he would allow that. Now I do think it's the same person who grades it for everybody. Usually the not even the TAs for that professor do. It's usually someone else in the math department that grades these all. So probably that you would be allowed to do that. So if you do want to make it cancerous, you can. I mean, you can get it up to I don't know, like at one point I was like 70 lines of code, and I managed to get it down to like 35. But I mean, nothing. I mean, it is nice just being done with 4 lines of code besides a function statement. I mean, that is. I mean, it is really that simplistic. At the end of the day, if you want to know how to make it hard, I can tell you how to make it hard and tell you how to make it do the whole lab. But um, I assume you don't want to spend an absorbent a large sum of time on that. Yep, no problem. I'll put a link to the what I'll do is I'll also put the link to that broken link on the GroupMe. Also, I'll put the link for the recording of this on the GroupMe. But does anybody have any questions left? I can help anybody with decoding. You're welcome. Welcome. Yep. I don't have any. Oh, yeah, I was saying earlier, yeah, I should mention again. Anyone who has any questions before at any time can DM me. I don't have notifications turned on for any group chat, so I'm not likely to see anything posted in the group chat, at least until I decide to look. I mean, I tried leaving the notifications on, but I mean, the stream would never stop, so I had to eventually mute those. But yeah, if you DM me, I'll notice and I'll respond. So anybody can do that. Oh, show 7. Hi. Do you want to see like the code for 7 or like the assignment 7? I mean the assignment directions for 7. Hi. So 7 ends up you end up doing the same thing you did for what was it? 5, which was where you did technically number 2 symbolically. I mean the 2 through 5 are all using the same thing, but yeah, you're going to use the same method you did for 5, which is this section here. And then you're going to graph it, and you're gonna have two of these. You have 2 of these, so I just put little notes, just like repeat. And I mean that's really all there is. Now one of the things they did establish for oh no, never mind. But this ends up going. Yeah, like 6 and 7 end up being not as much more of just conceptual on the comments, and it's not really anything new with the code. So I mean, it's not, these aren't really, and also the code I showed here, I was just copying and pasting from the links. So this isn't me giving away free code. They already gave away the free code. So I just showed like what variables would go where. You'd have, of course, have to plug those in yourself. And any times I did use an actual variable value, I did scramble it. Usually I was just omega f that I scrambled, but or a, I forget, I don't know, whatever. Any other questions? Yeah, I don't think anybody's strolled in a while now. Oh, you're welcome. Now while I did say I was gonna leave this, I was gonna let this run till 12:30, but I was gonna stop at admittance at 11:30. But I mean at this point, I don't want to I don't know. I did say I would give the extra hour, but I figured that people would need it. But I don't know. Victor, do you think I should just close out the meeting, or? Yep. You.
Oh wait, it's only the 3 of us. I just realized that now. I guess if everybody's questions have been answered, there's no reason to keep going. So.
I mean, I don't. I did make it. Yeah. I really do doubt anyone's gonna. Well, and technically, I did say that I was gonna stop admitting people at 11:30. Yeah. So at this point, what I'm gonna do is, I'm gonna save the group. I'll save this file here for this. Just put this. Let me put that down. I'll save the chat. Oh no, that's just inputting. Never mind. Yeah. So Victor, you think I should just close this out? I mean, I don't think this is gonna.
Yeah, I guess there's no point, because